Hello and welcome to the What's New webinar of the Huygens 22.10 version. My name is Thomas Ehrenkron and I will show you the new features of Huygens. We have a brand new tool in the localizer, but first I'll give a short recap of what the localizer does. The localizer is used for single molecule localization microscopy. Here we have a time series with particles lighting up in each image. We find these particles as localizations and store them in a table. You can process the localizations or visualize them in a single higher resolution image. The workflow is very user-friendly, allowing you to optimize the settings interactively. The process is also very fast, especially on the GPU, and it's very accurate even with high background noise. Finally, it contains a PSF distiller for Z calibration in 3D localization. The new tool to help you analyze your localizations is the cluster analyzer. We employ two algorithms for clustering these localizations: the focal and the dbScan algorithm. We provide an in-tool tutorial to familiarize you with its functions. The tool contains some specific analysis presets to compute information about the geometry, closest cluster, and co-localization. A more in-depth explanation and demonstration of the cluster analyzer will be in a webinar on the 22nd of November. Next, we have new features in the Object Analyzer. To briefly recap what the Object Analyzer does, it segments images into objects. Then you can select regions of interest and analyze the geometries, distances, or co-localizations of these objects. New in the Object Analyzer is the ability to export segmentation labels to an image mask. We have more parameters to base the coloring of the objects on. We have a new column option to get the average intensity for each object. And finally, if you have disconnected regions of interest, each region gets its own row in the table, so you can view its properties separately. We have improved the MIP renderer. And MIP stands for Maximum Intensity Projection. MIP rendering is a way of visualizing 3D data on a 2D screen, where you visualize the highest intensity voxel in your line of sight. We have improved the interpolation to get a better image, especially when zoomed in. Here you can see the standard way of interpolating, and here is the result of our new interpolation. This is explained more in the webinar on 3D rendering that you can watch on our website. We've also improved the lookup table editor. A lookup table stores which color corresponds to which intensity. Now this editor is combined with the contrast editor in a more user-friendly tool. This is explained more with a demo in the same webinar as the MIP renderer. We added a convolution option for SoRA spinning disk images. When you load a SoRA image, a window pops up where you can fill in all parameters, and it displays at the bottom whether your parameters are reasonable. You can also access this window from the Microscopic parameter window when you select the SoRA microscope type. Here we have a deconvolved image next to the raw image. As you can see, the deconvolution is a significant improvement over the raw image data. Similarly, we added support for the VisiTech iSIM microscope. Again, you can select the parameters in the Microscopic parameter editor. Here on the right you can see a raw image, and this is the deconvolved image. The image becomes much clearer after deconvolution. For array detector images, we have added a quality control option. Now you can visualize the total intensities per channel for each detector and store them in a table. It is also possible to verify the measured apparent shifts between the detector images. These are fitted to the array detector layout, which is then used for optimal array detector deconvolution results. The new array detector quality control option is presented in a separate stage during the deconvolution wizard for array detector images. It can also be opened in Huygens Professional from the main menu bar under the Analysis category. For more information, you can watch the webinar on the Huygens array detector on our website. We improved the status colors of the microscopic parameters. Parameters that you have verified now have a green check mark, while values read from the file have a green dot. We have better file support for the OME-TIFF format. There's a new OME-TIFF writer, so now you can also save your images to the OME-TIFF format. It supports up to 5D images in a single file, and unlike TIFF, you can now store the microscopic metadata as well in the same file. There are also no scaling issues like contrast stretching or clipping, since we store the floating point data directly in the file. We also improved the OME-TIFF reader to better parse the metadata, and we better read the different OME-TIFF configurations. We also improved the other readers and writers. We have now full support for Olympus OIR files on all platforms. We can read JPEG and extract compressed TIFF files on Windows. We now better read the file dimensions of TIFF files created by ImageJ. And we better read the metadata of Olympus VSI and Nikon ND2 files. Finally, we can now write array detector images to the TIFF format. Lastly, we have a new Mac installer specifically for the ARM-based M1 chips. This means that if we use this installer, the program does not have to be converted from x86 instructions to ARM instructions. This gives significant faster computations that varies from 10% to up to 50% depending on the operation. In summary, we have a brand new tool, the Cluster Analyzer, and the webinar for the Cluster Analyzer is on November the 22nd. We have new features in the Object Analyzer. We have an improved lookup table editor and improved MIP rendering. We have new deconvolution options for SoRA and VisiTech iSIM images. We have a new tool to determine the quality of your array detector images. There's the option to write OME-TIFF files, and we can now better read this file type. We also improved the other readers and writers. Finally, we added a new installer for the new M1 chip for Macs. This was the What's New presentation on the Huygens 22.10 version. Thank you for listening. If you want to try Huygens for yourself, you can request a license via svi.nl/license request, or you can email us at info@svi.nl.